And it looks like what we're going to do first of all is we're going to define evaluate. Oh, but remember we already know these, right? So we don't really need to look at our book for this. What does it mean to evaluate in math terms? What do they mean by this? Does anybody tell us, Blake? Find a value. Okay, so we're going to find a value for an expression. Yeah. Yes, Adam? Are you going to read the book's definition to us? How does the book's definition go? Did you see it?
Evaluate expression is to find its value.
Okay. So yeah. So if we're going to evaluate, then maybe the thing to do is just to keep it as simple as we can to remember it, as Blake said, to find its value. And notice I didn't put an apostrophe in ITS. I was kind of fussy about spelling. Did you notice that on your old-time assignment? I want you to become good spellers. I want you to use words properly. We do not put an apostrophe in this it's because if you put an apostrophe in it, then it makes sense to read it is. So it makes sense to say, to find it is value. And it makes sense, doesn't it? No, so we leave the apostrophe out. Okay, so we're going to be adding to our learning goal today. We still have the same learning goal as yesterday. In your homework, you're still going to be translating between words and algebra. But today, we're adding a new learning goal to it. I can evaluate algebraic expressions. So that's what we're going to write here by number 3. Okay, I can evaluate algebraic. That's quite a word. Expressions. I can evaluate algebraic expressions. We're adding that objective, that learning goal to this lesson now. So we really have 2 learning goals in lesson 1.8. Translating between words and algebra and evaluating algebraic expressions. Okay. But before we move on, we've already defined the word evaluate up there, so it's right there. And we notice the word evaluate is used in our learning goal. But notice what other words are used. Algebraic expressions. What does that mean? What are algebraic expressions? What's the definition for that? What's an algebraic expression? Go ahead, Taylor.
An algebraic expression may contain variables, constants, and/or operations.
Okay. Variables, constants, and/or operations. Guess what it has to have? You know that word "or" was thrown in there. What does an algebraic expression have to have that a numerical expression does not have? Operations, they both can have those. Like a variable. A numerical expression, the other type of expression, can't have a variable. So what made a numerical expression into an algebraic expression was it took on a variable in it. What doesn't either type of expression have in it? And I need to clarify this. I need to make sure you understand this. What does neither a numerical expression or an algebraic expression have in it? Ever, if it's an expression. These cute little pencils to give away. I wonder if anybody knew the answer for one of those cute little pencils. What does an algebraic and what does an algebraic expression and a numerical expression never have? Adam?
Variables?
Nope. An algebraic expression does. An equal sign, Andrew gets the pencil out, I'll get it for you. Okay, and an expression never has an equal sign. So if you have to write an expression and you have an equal sign in it, I have to be like, they don't understand what an expression is. Okay? So we don't want equal signs in it. So check it out at the bottom of page 7. Here's what we're going to do. We're going to practice evaluating algebraic expressions. Would you write down the algebraic expression for 3a that is in your book? Find it. 3a algebraic expression. Write it down. We always want to start by writing down the algebraic expression given to us. Is it mn? What does that mean, mn? What operation's invisible there? Multiplication. This means m times n, doesn't it? We're supposed supposed to evaluate it, and let's write this down too, when m equals 3, n equals what? 2. Write that down also. We are evaluating the algebraic expression mn, also known as m times n, when m is 3 and n is 2. So we have the algebraic expression there already. Now we substitute in, so we substitute a 3 in for the m. I'm going to put a multiplication dot there. We could just use parentheses around our 2 to show multiplication also, but we do not use the x because that could look like the variable x, right? We can mistake it for the variable x. So now we're in algebra. We're going to use multiplication dots. And 3 times 2 is 6. Our evaluation, find its value. The value for mn, when m is 3, n is 2, is 6. Okay, you do everything, you do 3b now. You write down the algebraic expression. You write down what p and q, or p and n, are supposed to be in this problem. Just like we did. So make your, because this is how you're going to show it in your homework. So copycat 3a. Said use the right things on 3b.
At this time, could we get all 8th graders with the last name starting with N through Z to the half lobby for pictures? Thank you.
When you're done, will you look up and see if you need to challenge me, or do you agree with me, or, and you know what? You need to have all this stuff showing. So if you don't have all this stuff showing, there's trouble in paradise. Yes, supposed to be an N. Oh, you're right. Thank you. Good challenge. There should be an N, not an M. Okay, there's an N. Any other challenges? Anything else that we want to make sure is cleaned up and is done properly? We all agree? No? Okay, cool. Okay, let's do 3C now then. And here's the deal. In algebra, when things start getting really complicated, if you get in the habit of working vertically, what does vertically mean? Up and down, right? Vertical is up and down. So if you started something and work your way down, instead of trying to go all the way across the page until you run out, then you're going to start going. If you can follow it easier if you do a vertical alignment rather than a horizontal alignment going on. Okay? So we have our algebraic expression, we do our substitution step, we have our value from evaluating. Find its value. Okay? Anybody need to challenge 3C at all? Can we all agree on it? Okay, this is how you're going to show work for those problems in the homework. That's going to be the new kind of stuff that you'll be doing in your homework. Okay, we're going to move on to number 4, and we're going to call this our application problem. So in other words, I'm going to use a new word for it. Instead of you saying word problem, because we right away, have an anxiety attack with a word problem. Let's call it an application problem. Maybe that'll feel better. Okay? So, we're going to do the check it out. So write this down. Where did this come from? This is what we're doing right here. We're doing the check it out. Write that. where's this coming from? Because we're not gonna write word for word what the problem is, but we wanna know where it came from. And it's gonna be found on page 8, so we're gonna identify that also in our notes. We want our notes to be useful and helpful. That's the goal with notes. So would you read that problem to yourself? In your book, you can't look at me and do it. Before we even start doing 2A or 4A and 4B, before we even start doing them, I want us to make some sort of a statement, some sort of a phrase statement that says, here's what I learned from the reading I did before I even went on to 4A and said, what do they want me to find? What did you learn by reading to make one sweater, da 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 da? What, just that one, it's just a one sentence. What did we learn that we can write down for this problem? What's important information? I want somebody to say it. Yeah, go ahead, Blake.
Like one sweater, you need 20 ounce bottles or something.
You need 20 ounce bottles to make a sweater?
You need 14 20 ounce.
You need 14 20 ounce bottles to make a sweater. Do you guys want to agree with him? It takes 14 20 ounce bottles to make one sweater. That's what Blake found out. Is that what yours says?
Oh, he's reading the recycling application.
Oh, you're reading the example problem.
I did the same thing.
Yeah, we're going to check it out, you guys. We're going to check it out. Below example 4.
60.
Yeah, take 63. Good job. Okay, so we're just going to write that down right now. We're going to say 63 bottles. And we're not going to make this really long. We're not going to say they're 20 ounce and they're recycled and blah, blah, blah. We're going to say 63 bottles for one sweater. Okay? That's important information. 63 bottles for one sweater. This is how we attack application problems. Now we'll go on to 4A, and we'll see what do they want us to do in 4A. Okay? What do they want us to do in 4A? Write an expression. So what can't it have? What can't it have? It's an expression. Equal sign, so no equal signs allowed here. Write an expression for the number of bottles needed to make S sweaters. In other words, S is standing in for the number of sweaters. So what algebraic expression, because there's an S involved, so that means it's an algebraic expression. What algebraic expression, go ahead and write one down that you think would show how many bottles are needed to make S number of sweaters. Okay? Who wants to share their algebraic expression for 4A? Be brave. It's okay if you're wrong. Be brave. Taylor.
63S.
63S. So in other words, we're going to multiply 63 times S, but we don't have to show the time symbol, right? To get how many bottles we need altogether. Yeah, that makes sense to me. 63S. Okay. So that represents the bottles needed to make S number of sweaters. So if you wanted to make 2 sweaters, what would you do?
Take 63 times 2.
You take 63 times 2. This is what you should do when you have to set up your own expressions. You should say, let me make up my own little situation then. What if I want 2 sweaters? How many bottles do I need? Well, let's see if my expression works. Would it make sense, the answer I get? So if we took 63 and took it times 2, our number of sweaters we want. Anybody happen to know what 63 times 2 is? 126. Does it make sense that you would need 126 bottles to make 2 sweaters if it takes 63 to make 1 sweater? It should take more, shouldn't it? Yeah, it should take more. It's like we got more, so it makes sense. We should always see, does it make sense? Okay, 4B. Find the number of bottles needed to make 12, 25, and 50 sweaters. Okay, so here's what we're going to do. Let's make a table. Okay, so S, and this would be our expression that we're going to use in it. and we're supposed to do it for 12 and, what was it, 25 and 50. So we're gonna do 12 sweaters, we're gonna do 25 sweaters, we're gonna do 50 sweaters, okay? And so we are going to take okay, I'll let you use your calculators. Get them out. 63 times 12 as a time saver. I know we can multiply. I know we can. I have faith in you.
I just added it.
You did it? Okay, let's see if you're right with these calculators. Okay. How many bottles are needed to make 12 sweaters? Adam? 756. Agree with him? Cool, then we'll go with that. 756, and what's its label? What are these, sweaters? Bottles. Okay, finish filling out your table and then we'll compare. I did my arithmetic in my head, so you need to not just change your answer if you think I'm right. You need to challenge me if you think I'm wrong. I didn't use a calculator. I didn't use, scratch paper. I was just doing it up here. So everything on.
Oh, no, that's right, yeah.
So we all agree? Okay, and all of them have labels, right? We want to make sure we understand that these represent the number of bottles. That value that we got from evaluating represents the number of bottles. Okay. Any questions on our second learning goal that's been added to our first one? We're going to actually practice both of them in your homework now. So you need yesterday's notes. So let's find those. You need today's notes.